Hi everybody. Today, inshallah, we do review chapter 5. In chapter 5, there is three sections. Section 1 talk about characteristics of light. Section 2 talk about flat mirror and reflection. Section 3 talk about spherical mirror. Now let we start with section 1. Characteristics of light. Of course, light as a electromagnetic wave, it has time period. Time period equal 1 over f. What is f? F is frequency. So just inverted of frequency is time period. Frequency also equal 1 over t capital time period. Okay. Here electromagnetic wave, why we say electromagnetic wave? Look here in this graph, you will observe two waves, one wave red color, the other wave blue color. So the blue color is electric field, but here red color magnetic field. The magnetic field perpendicular with electric field. That is why we say electro then magnetic. Electromagnetic, two words. We mix it two words. That's why the electromagnetic wave includes two field, electric field and magnetic field. Both, it has one direction. This direction called distribution of light wave. Also here, look at the peak of, look at the magnetic wave, for example. Here, from peak to peak, this distance called wavelength. From peak to peak, called wavelength. So, during one wavelength, along of one wavelength, a long time, this time called periodic time. Okay. Number of wavelengths in 1 second, per 1 second, this is called frequency. So frequency, how many the wave can do wavelength per 1 minute. This is the conception of frequency. Okay, here electrospectrum. What does it mean, electrospectrum? As we said, the electromagnetic wave, it has one speed, but in fact not all electromagnetic wave visible, not all visible, only visible from here, look here, from 700 nanometer to 400 nanometer. So here, this is the range of visible light. So visible light, we can see the the color of wavelength. The color of electromagnetic wave. You can see 7 color rainbow in this spectrum, from red, yellow, red, orange, yellow, green, blue, indigo, violet. So here we can see only this spectrum. That's why it's called visible spectrum. What about infrared, radio wave, microwave? Uh, these uh, these waves, the human eye can't see these waves. Okay, so from ultraviolet, okay, ultraviolet, X-ray, gamma ray, also we cannot see these range of electromagnetic wave. But here it is important, when wavelengths increase to the right side, wavelength increase, the frequency decrease. So there is a inversely relationship between wavelength and frequency. Look at the left side. When we go to left side more, step by step, the wavelength decrease. The wavelength decrease, but frequency increase. So this is the relationship between frequency and wavelength. What about speed? What about velocity of light? Velocity of electromagnetic wave? Same velocity, same velocity. All these spectrum, it has same velocity. So, for example, X-ray, gamma ray, ultraviolet, visible light, infrared, FM, AM waves, radio wave, both radio wave. All these waves, it has same velocity, which is equal, constant, 3 times 10 to power 8 meter per second. Okay, let me go to the another slide. In this slide, we will discuss wave speed equation, which is V equal frequency times lambda. This relationship between 3 factors: frequency, lambda, velocity. Sometimes we need V as a speed wave, meter per second unit, but with light we use C, the letter C. So here V, speed of light. If you say C, same. F, frequency of wave, hertz. The unit of frequency, hertz, or you can say second power negative 1. Lambda wavelength is meter. If you remember in chapter 1 in first course, we studied how we can convert nanometer to meter, millimeter to meter, centimeter to meter. So meter international unit, we have to convert all the other units to meter. If we have kilometer, we have to change to meter. If we have nanometer, you have convert from nanometer to meter by times 10 to negative 9. Let we see the other slide. In this slide, we have practice about wavelength and velocity lambda relationship. Read the question. Gamma ray frequency, this is frequency of gamma ray, 3 times 10 to power 21 hertz. See, the unit of frequency hertz. Now what's the question? Find wavelength of gamma ray if you know the speed of light equal 3 times 10 to power 8 meter per second. We have rule lambda equal c over f. I said c, velocity, speed of light, 3 times 10 to power 8 divided by 3 times 10 to power negative 21. So here we have mistake and be careful, please. I'm sorry about this mistake. 10 to power negative 13 again. Here 10 to negative 13, because now I am recording, I can't do this. Okay, there is this is negative 13. Again, the answer is 10 to power negative 13. This is a mathematical rule. I'm sorry about this. Okay, let me see another one. Section 2, flat mirror. Here, as I said, each mirror, it has two surfaces. Here we have smooth surface to the right, to the left, sorry, and hard surface to the right. So if you see, read here object. Where is object? This arrow, this blue arrow, front of mirror, front of smooth surface. So look at the object, then look at the image. Listen here, image behind mirror, image green color. What we can deduce from this diagram? Number one, the length of object equal length of image. So this is same size. Here you can say m equal 1. Don't forget this. With flat mirror, m equal 1. So what do you remember now when m equal 1? So q equal p. Here in this diagram they use it d naught as p, d naught. Look here, from point C to point B, this distance is p. This is object distance. This distance equal from C to D. From C to D, same distance. So from C to D called Q. From C to B called P. P equal Q. M equal 1. Because in mathematics, when we divide same number, for example, 10 divided by 10 equal 1. So that's why P equal Q, M equal 1, same size. No smaller, no biggest. Okay. What else? Because the image behind mirror, so this is virtual. This is virtual. Again, the properties of image in flat mirror: virtual, same size, upright. Upright. How do you know upright? Look at the blue object, the head to up, the head of a row to up. Here, the head of image also to up. So this is upright, not inverted. Again, upright, virtual, same size. Let we study next slide. Here, section 3, we studied section 3 carefully. I think we studied convex mirror and concave mirror. We said a concave mirror, it has 6 states. Convex mirror, it has 1 state. If you remember, with the concave mirror, in the 5th state there is no image. There is no image. And in the 6th state, concave mirror, the image, it was virtual, upright, biggest. The other states, 1, 2, 3, 4, these states, the image, it was real. The image, it was real. Concave mirror has P positive and P positive, Q positive, F focal point positive, all positive, unless 6th state Q negative. With convex mirror, we have 1 state. It was virtual, upright, smallest. Okay. Here we have homework. This homework as a table. The first column, types of mirror. We have 2 questions. 1 question about concave mirror, the other about convex mirror. In concave mirror, here first row, here we have focal point 20 centimeter. P equal 12 centimeter. What is unknown? Q and M. I want to give you some hint about this question. Because F equal 20, so R equal 40. This is number 1. Number 2, because P less than F, so if you remember, P is the distance of object. Here, distance of object 12 centimeter, so less than F. What does it mean? That is mean the object located between focal point and mirror. What else? That is mean this is 6th state. What else? That is mean M should be bigger than 1. The answer of M should be bigger than 1. What else? Q should be negative because virtual, because this is 6th state. So here when you solve the question, listen to me, when you solve the question, should be Q negative answer, and Q should be less than 12. For example, negative 10, negative 9, see? Less than P. Negative 8, any number less than 12. Why? Because M should be less than 1, smallest. Biggest, I'm sorry. Should be M greater than 1. Q should be greater than 12. Again, this is This is not convex mirror. I'm talking about concave mirror. In concave mirror, m should be greater than 1. Okay, greater than 1. Why? Because biggest. Upright, virtual. So because biggest should be q greater than 12. Like what? But negative. Like negative 13, negative 14, negative 15, negative 16, etc. Should be greater than 12. Greater than 12. Again, my student, my dear son, daughter, listen to me. Should be q negative, negative, any number greater than 12. Like negative 14, negative 16, negative 20, like this. What about m? M should be the answer should be less than, sorry, greater than 1, greater than 1. Yes. Now, convex mirror, the second question. Convex mirror, this is 15 centimeter, F, Q 20 centimeter. What is unknown? P and unknown. Listen to me. When you use mirror question, should put negative 15 and negative 20 because this is convex. I expect because this is convex mirror should be m less than 1 and p should be greater than 20 but positive. If you did use negative, you did mistake. P should be positive. I said positive. P should be positive with all mirrors. Thank you so much. I like you. You can follow me with by chat in Edmodo or message or in Zoom meeting. Thank you so much. I like you. Bye bye.